Okay, beta, let's resume.
So we have understood the concept of true altitude now. We have also understood the concept of true zenith distance now. Very, very important concept from the horizon system point of view. So all the things, new things which we discussed in the horizon system, they have been added up in the same diagram. The diagram now shows you both the systems. You see the equinoctial system also. You see the horizon system also. You see the references from the horizon system as well as the equinoctial system. Now, having understood both these systems of reference, that is the equinoctial system, which is based on equinoctial and the celestial poles, and the horizon system, which is based on the rational horizon and the zenith and nadir, or the vertical circles. We can now move on to understand the concept of PZX triangle. So we will use the two systems which we have just now discussed to understand what is this PZX triangle. So PZX triangle concept is what we use in celestial navigation to solve most of the problems. In fact, I would say the entire celestial navigation is based on the PZX triangle only. As I told you in the beginning that the concept of celestial sphere was assumed so that we are able to use spherical trigonometry to fix up the position of the observer or position of the ship using the spherical trigonometry formulas. These formulas are applied to the PZX triangle only. So let's go ahead and try to understand this. The diagram which you see on the right side includes only the things which we have discussed till now. We have discussed the equinoctial system. You see the equinoctial here. And you have both the poles. You can see the south celestial pole here. This is the north celestial pole. The semi-great circles joining them are the celestial meridians. You can see the celestial meridian represented here. Then you can see the rational horizon. Coming to the horizon system now. This is the rational horizon. You can see the nadir as well as this topmost point on the diagram is the zenith. Semi-great circles between the zenith and the nadir, they are known as vertical circles. So you see this particular vertical circle here. And this is the celestial body, the red color star which you see is what we are referring to right now. So if you consider this arc of the vertical circle contained between the horizon at point H up to the center of the celestial body, we just now saw that this is the true altitude of the body. So all these things we have discussed already. There's nothing extra here. And now we will try to see or find out the concept of PZX triangle, which is hidden in this particular diagram only. Now we know that this is the equinoctial and the axis of the earth extended toward the celestial sphere. They meet at both the celestial poles. So this point here is the north celestial pole. Let's mark it as P. I have written NC also in short just to show it that this is the north celestial pole. This point is represented by P. We have seen this is the rational horizon. This is the position of the observer, and a line drawn from the center of Earth passing from the observer's position meeting up to the celestial sphere. It meets at what we call as the zenith of the observer. So this point is the zenith, and let us mark it as Z. We have the zenith point plotted on the diagram now. The celestial body's position is represented by X. So let's mark a X here. So we have the P point representing the north celestial pole. We have the Z point representing the zenith of the observer. And we have the X point representing the celestial body. And covered by these 3 points, that is P the pole, Z the zenith, and X the celestial body. This particular area which is covered by these 3 points is the PZX triangle which we are interested in. So you can see this PZX triangle on the celestial sphere, which we use to solve most of our celestial navigation-based problems. Now let us try to go a little deep into the different parts of the PZX triangle.
Beta, up to here, any doubts in your mind? Okay, so shall we proceed ahead now? Details of the PZX triangle.
Yes, sir.
Yes, sir.
Okay. Okay, beta, great.
Now let's concentrate our attention to the Earth in the center. You see this circle here represents the equator. And this particular position, which is exactly on top of the Earth in our diagram, represents the observer's position. Now, if you measure this arc between the observer's position and the equator, where I'm highlighting using my laser pointer, so this arc of the meridian between the equator and the position of the observer is the latitude of the observer. Angle at the center of the Earth, or the arc of the meridian contained between the equator and the particular position, is the latitude. Now, equator is projected onto celestial sphere as equinoctial. You see this Q point is represented here. The Q point represents the position of the equator on the celestial sphere, and the observer's position is projected onto the celestial sphere at the zenith. So at this Z point is where the observer's position is projected. So this arc which you see from the Q point to the zenith of the observer represents the latitude of the observer. Now, since Earth and celestial sphere are both concentric circles, whether you measure this arc on the surface of Earth or you measure it on the celestial sphere, the arc is going to remain the same. So ZQ or QZ is the latitude of the observer. Now we also know that from the equinoctial to the celestial pole, that is NCP. So pole to the equinoctial, P to Q is 90 degrees. Every point on the equinoctial is 90 degrees away from the celestial pole. So P to Q is 90 degrees. Z to Q is the latitude of the observer, and this tells us that P to Z, this side of the PZX triangle, that is P to Z, will be 90 minus latitude of the observer. So let us highlight this side in yellow. You see the highlighted side PZ of the PZX triangle, and this is equal to 90 minus latitude, also known as colat. So PZ side of the triangle is equal to 90 minus latitude equal to colat of the observer.
Beta, any doubts up to here?
सर ZQ को डेक्लिनेशन नहीं बोलते,
नहीं बेटा,
डेक्लिनेशन बोलते हैं ना सर?
डेक्लिनेशन सेलेस्टियल बॉडी की होती है बेटा. Z is representing the observer's
ओके ओके,
position. So ZQ is the
ठीक है
latitude
सर.
of the observer.
ओके सर, ओके.
Okay. और बेटा, any other doubt? Okay, very good. Let's proceed ahead.
Let's also mark out the latitude of the observer. So you see uh, equinoctial to the zenith. This arc represents the latitude of the observer. So we have labeled here as latitude on the diagram. So you can see the latitude ZQ and the colat P to Z, and both totaling up to 90 degrees. Pole to the equinoctial P to Q point is equal to 90 degrees. Now let's move to the other parts of this triangle. Now we move on to the PX side of this particular triangle, Papa X-ray. So this PX side, Papa to X-ray, is known as polar distance. You see, X represents the celestial body and P represents the north celestial pole. So this arc basically tells us how far away from the pole the celestial body is. So this is known as the polar distance. Now, this particular dotted line which you see going from the north celestial pole, passing from the star and going up to the south celestial pole, this dotted line is the celestial meridian of the star. You see, we discussed the celestial meridian in the equinoctial system. So this is the celestial meridian of the star. Pole to X to the south celestial pole, and this celestial meridian cuts the equinoctial at this particular point. Now, from this point, if you measure the arc of the celestial meridian up to the body X, this particular stretch of the celestial meridian, what is this? This is the arc of the celestial meridian contained between the equinoctial and the center of the celestial body. This is the definition of declination. I told you declination basically tells us how much north or south of the equinoctial a particular body is. So if you look at this arc, it represents the declination of the celestial body. It tells us how much north of the equinoctial our celestial body is. And we also know that pole to equinoctial. So from the equinoctial, if you go along the arc of the celestial meridian up to the pole is 90 degrees. Every point on the equinoctial is 90 degrees away from the pole. So pole to equinoctial is 90 degrees. Equinoctial to the celestial body, this arc of the celestial meridian is the declination that tells us that the px side, which we call as the polar distance, will be equal to 90 minus declination. So I have highlighted this px side with the maroon highlighter now, and this side is the polar distance of the body, telling us what is the distance of the body from the nearest pole, and this will be equal to 90 minus declination.
So have a good look at the diagram, beta. Let me know your doubts. Okay, very good. So shall we proceed ahead?
Yes, sir.
Yes, sir.
Okay, great. Let's go.
So this is the PX side of our PZX triangle. So two sides of the triangle are understood. Now let's move on to the third side. Now if you move on to the third side of the PZX triangle, the third side passing from Z going up to the X and going up to the nadir is the vertical circle passing from the body. This is the vertical circle which is passing from the celestial body. And we just now saw that the arc of the vertical circle contained between the rational horizon and the center of the body, that is h to x, is the true altitude. You see it is still marked in this diagram. This is the true altitude of the body. And we also know that any point on the rational horizon is 90 degrees away from the zenith. So Z to H is 90 degrees. H to X is equal to the true altitude of the body. This tells us that Z to X will be 90 minus true altitude. And this particular side is known as the true zenith distance of the body. In short, TZD of the body. So I have highlighted this side in green color. Let's label it as the true zenith distance, TZD, and it is equal to 90 minus true altitude. So 90 minus true altitude, the side is the TZD, the true zenith distance, and it is represented as the ZX side of the PZX triangle. So you can see the PZX triangle here represented. P to Z is 90 minus latitude or co-latitude. Z to X is the true zenith distance or 90 minus true altitude. And P to X is the polar distance of the body, in this case 90 minus declination.
So have a good look at the diagram now, beta. Let me know any doubts in any of the parts, any side. All okay, beta? All clear?
Yes, sir.
Okay, all right.
Yes.
So this is the same PZX triangle which we are doing from pre-C times. So we have more or less completed. We have seen the three parts of the triangle.
So these are the three sides of the PZX triangle.
Okay, so beta, after the PZX triangle, now the next concept which comes is to convert this diagram into the plane of the rational horizon. So right now we are looking at the celestial sphere. ये सारे references हमने celestial sphere पे बनाए हैं. The equinoctial system, both the celestial poles, then the horizon system, the zenith and the nadir, the vertical circle, the celestial meridian. ये सारे के सारे हमने celestial sphere पे बनाए हैं. And now we will convert it into the plane of the rational horizon. Why we wanted to convert it to the plane of rational horizon? The reason is, beta, this diagram is a complicated diagram. So it's a 3D diagram, and for question solving we need to make the diagram, and it will be very difficult if we have to make this kind of a diagram for each and every question. So we are trying to simplify it so that it is very easy for us to draw this diagram, and once we are able to draw it, we will be able to solve any question which is based on this. So that is the purpose. Because if you start to make this diagram, 20 minutes are given to you for solving a question. The diagram's drawing itself is going to take 10 or 15 minutes. So it will be difficult to complete the question. So we will make this rational horizon diagram now. We will correlate all the parts. We will show this PZX triangle on the plane of rational horizon, and then we will be able to easily draw it in time and solve the question. So that's the procedure going ahead. But it requires a little bit of effort. So मैं आज इसको नहीं करने वाला हूँ बेटा. I am going to give you a break for now. We have understood the three systems: horizon system, equinoctial system, and we have understood the PZX triangle also. So just get this thing clear in the mind and let it go into your brain. And then in the next session, we will convert it into the plane of the rational horizon. So have you done this in pre-C or in second mates like this, like the way we did it now?
यस सर, आपने ही समझाया था व्हाइट बोर्ड पे.
The same diagram
सर
I
ऐसे
must
तो नहीं
have.
किया था लेकिन किया हुआ है.
Okay. So was it easy to understand from the diagram?
Yes, sir. This
Yes,
diagram
sir.
is a
Yes sir, now is it.
very good sir, diagram.
Very good. So great. Because why I was asking this, because this diagram is not there in the book also. So if you want, you can
Yes,
take
sir.
a screenshot and keep it with you. Book में दोनों system अलग-अलग दिए हुए हैं, and they are not given together. So it becomes difficult to mix them up in the brain and visualize the PZX triangle. But in this diagram, you can see both the systems simultaneously, and you can appreciate how this triangle is being made. So you can take a screenshot and keep it safe with you. So anytime you have doubts understanding the PZX triangle, just open it up and it should be clear.
Yes, sir.
Okay, so that's all for this particular class from my side. If you have any doubts or queries, you can ask me. All clear?
Yes sir.
Okay, great. So ठीक है बेटा, then we call it off for the day. There is still some time left. You can practice any of the homework if it is pending. So you can utilize this time. So see you in the next lecture, beta. Bye bye till then.
Okay sir.
Okay, sir. Thank you.
Okay, beta. Thank you.
Thank
Bye.
you, sir.
Thank you.